All right, so we are back a little while later from that last video that we've done today. So let's go ahead and do this one, and then probably the next one will be later on today or tomorrow. Because again, I want to finish this by um, Saturday. So we got to go ahead and get going on this. So we have this guy. This is X. Oh, this is y-axis technically. This is y-axis. So here we could drive joint. Joint limits, minimum, 0. Well, minimum and maximum should be okay. This is 25 inches. Oh, and that means this minimum is 25 inches and maximum is 0. What? It's going the wrong way. So this is like 30. Maximum is 30. Minimum 520. There we go. Alright, so we got that one side. Let's go ahead and do the other side. Same deal, but this time what we're going to do is to make it easier on ourselves, we're going to go ahead and do that, and do that. And basically we're going to rotate this guy here, and then what we're going to do is we're going to move this guy really, really close. There we go. So that's negative 8.5. I'm guessing it's plus 30 milliliters. What is it? Oh, not 0.30 plus 30 milliliters. 30 to the bottom. Technically, it's not. Okay, so that's to the bottom there. Let's just do this. Okay, and then let's go back. Let's create another sketch again, or actually let's move this one over here. And then let's go ahead and project this. And again, this needs to be 30 millimeters. So 30, so that's 4.58, 4.58 here. And there we go. So now okay, so that's good. Make sure all of the sketches are hidden, which they are, it looks like. Wait, where's the sketches? That's weird. Anyways, okay, so this is gonna be a slider. And let's go ahead and move this on to the platform here. So that's good. And then this is also But this is actually a driven joint. So let's edit joint. See joint, rigid group, this group rigid. So this is so now if we drive joint, it should, yeah, good deal. There we go. So now it looks good, and they're set the right distance and the right height from each other, so that leaves a surface. So obviously another issue here is that this is obviously not going to work because we need to be able to have that piece of plastic clear here. So this thing needs to be just a little bit taller. It's a little bit taller this way and this way. Okay, and then actually what we'll probably do is this probably needs to be dropped down from the width here, so we could do that. Oops. 20 millimeters. So let's go back to the base. Let's go 10 millimeters from the bottom. So let's say that this is not here. Let's say this is 10 millimeters from the bottom. There we go. So now, theoretically, when we save this, save, we go to General Assembly, this will drop it down a little bit. There we go. All right. So, but still, this is a little short here. This is only, it's less than a 1/4 inch. Yeah, we could maybe get some sort of something on there, but let's see, what's the thickness of this? Thickness of this is 1 inch, so it's gonna be like 1.25 inches. 1/2 inch would be fine. So let's jump that up to 1.25 inches, or even 1 1/8 inches. Let's do 1.25 inches for right now, though. 1.25 inches. 1.5. And save that. Okay. General Assembly. Good deal. All right, so that looks good. So obviously from this, we could look at the joint limits. So we have 520 minus, well, technically it's 530, 520 plus 30, 520 plus 30. Millimeters to inches. So we have about 22 inches of travel. Out of 25 inches, we have 22 inches, 21.65 inches of travel. So 21.65 divided by 25. So that's just like I calculated kind of an 86% useful volume area there. Yeah, cool deal. Okay, so we have a good efficiency there as far as space, and these are big rails, so it should be fine. And again, they have a very high loading. M is kilonewtons per meter, which this thing's like a meter away. So like 5 kilonewtons. And again, we're going from newtons to pound force. Pound force, we have like 5 pounds. So it's 22 newtons, and we're talking kilonewtons here. So this thing should be pretty good. But again, we're only using one rail here, one rail there, but that should be fine. Should drive the cost down of having 2 rails. So let's go back to our general assembly. Let's look at our current weight. Properties. 720 ounces. Oops. Equals 45 pounds. Okay. 45 pounds. All right, good deal. Okay, so now what we're going to do is we need this distance here, from here to here, so that's 14.362. Let's go ahead and write this inside of the Trello. 14.362, and this is for the X gantry plate distance. Okay, so let's go ahead and add that card. So now we could go ahead and start the X, or the X gantry plate. And so the gantry plate, again, is going to basically be determined by the spindle, the height of the spindle, which we need to still get a definitive answer on that as far as the height. So I should send those guys a message, but I have it here, so let's go ahead and look at it here. Obviously it looks like the oops, what? Oh, apparently that did not work. I mean, this is basically the same deal. Yeah, this is the same deal. Just tell me the length? No. Okay. All right, so I was just looking at the piece there. So obviously we want this base because we want to put it against this guy, but in actuality it's not exactly that size. It is this size, which is L1, which is 50.5 millimeters wide. So we're talking 50. It's a rectangle, 2 points, center. So this is 50.5. Oh, but not inches though. We might go with the HA then, 65.2. Oops. It's in millimeters. It's 2.5 inches. Where's my calipers here? I mean, because that's pretty small. I mean, 2.5's not bad, but 1.5 is kind of small. Support that big of a cutter. So let's look at this one. Reason being is that it has this drop off right here. So there's no point in really having the metal going across it. I mean, you could have it up to that point because you're going to lose that anyways, so might as well have the strength. So, but let's model it as if it was the HA for right now, which is this one here. And the length overall is 65.2 or 92.2 because you're not going to lose anything if you go 92.2. So let's go 92.2 millimeters, 9 inches. Okay, so it's 3.63 inches. That's more like it. Yeah. Cool. So let's go ahead and stop that. Oops. Let's go back. Alright, so basically now we're going to go into the general assembly here. And then let's go ahead and drop in the spindle and kind of look at it. So let's get it up to the top face here. There's no way that this thing is correct, but let's just say it is. And then here I need it to be at least 3.5, so at least 5 inches of clearance, 5 inches. Wait. Cancel. 1.3. So let's just say plus, because it's like 3.5 to the top. I don't know exactly how much clearance I'm going to get on the collet. So we're probably going to need almost like 6 inches of clearance. So it's going to have to go up to there. But that's a big moment arm, but we could hold it down here. So this plate could be pretty big. And then this won't have such a big moment because we're kind of holding it down here. But the actual plate will go under here, and then theoretically this I want to have just the end mill clearing and just have 5 inches from the top of this plate to here clearance. Because I don't need the clearance for the end mill, I just need clearance for the end mill here. So here this could be like 5 inches and have no problem. Because I don't want this cantilevering because that'll add a lot of bending beam moment. So let's look at this guy. So this guy, so from here, ooh, this is almost level. Actually, it looks like they're two are slightly off of each other. Or it's going through the wall or something. Oh, they might be flipped around. Anyways. Yeah, this one's... one of them's not right. Anyways. So, basically what we need to look at is this plus N down from here, basically. So, N is this number here from the WR. So let's go ahead and draw another sketch, or let's just keep moving this one forward over and over and over again. So here WN, N is 12 millimeters. So that's N. So to go from N all the way up, it's 1.76. 1.722. So this guy is, let's just put 1.722 for right now. 1.722 to the top. And another thing is also how big this guy is. So basically this guy, hopefully it has dimensions. Oh, sweet, it does. So that's basically this. This is a 65 millimeter clamp. This is 3.1 inches there. So we need to have it at least have that actually, no, we don't. We need to at least have room for 2 of these blocks to clear each other. Because I think up there we'll use 2. Everywhere we're going to use 2. But we'll use one of these each. Because this is bigger than 65 millimeters as far as I know. 3 inches. 65 millimeters. Yeah, so this is already big enough for that part anyways, so you only need 1, which I like, but we'll still do 2 rails each. So 1.722 plus 5 inches. So here, plus 5 inches, plus whatever thickness I want it to be. I mean, it might as well be basically the size of the spindle itself, because we're not going to lose anything there. So it could be the size of the spindle, the length of the spindle, which is 240 something millimeters. Inch. .6 inches. Okay, there we go. Alright, so now what we're going to do is we're going to go here. Oh, plus we need a little bit of an offset for the bottom. So a little bit of offset for these holes in the bottom. So let's add a 1/4 inch on the bottom for the holes. Okay, so now what we're going to do is we're going to add a 1/4 inch on the bottom, just like we just did for the screw clearance. We're going to go back here. We're at 22 minutes. Okay, so, and then this is going to be on the side, so it's going to bolt this way. And C on that one, let's do the 20HA. Let's do the 20CA first for right now. So that's C 36. So 36 millimeters divided by 2. This is 36 millimeters divided by 2. Okay, so those are the holes there. And then, so that's that way. And then B, let's go ahead and do this. Do this. And then B, which is the height. Oh, but I did not, so we're going to have a little bit of clearance then there for the legs as the legs come off, but that's okay. So B is 6 millimeters. 6 millimeters. 6 millimeters. There we go. Okay, so now let's go ahead and go here. Point. Oh, something's not right there. Okay. Point is M5 by 6, or basically a clearance hole, which is the same clearance hole as this one here, which is little d, which is 6 millimeters. So let's go ahead, create hole. 6 millimeters, 6 millimeters, 6 millimeters, 6 millimeters. Oh, I have to shoot it first. So instead of that, let's go here, 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 here. Let's put it as invisible there. Then let's create a circle, and 6 millimeter. Uh-oh. Oh no, not 6 millimeter. No, that's this hole. This one needs to be, this one's an M5. So let's just say 5 millimeter for right now. Is it gonna touch? No, it's okay. Okay, then let's go ahead and do this. And this guy's gonna be about like 1/4 inch thick, up to 3/8 or so. Or maybe even, this is gonna be way more than 1/4 inch. Let's make this like 1/2 inch. 1/2 inch. And there we go. Can't believe that this B distance is so close. Wait a second. B is 32 millimeters. Is that what I put? It's not 6 millimeters. That's this. B is 32 millimeters. B is 32 millimeters. Oops. There we go. That's better. So yeah, let's jump this up. Let's do this to that. There we go. Let's do this. So we don't have to change all these all the time, and notice that there's a weird issue going on. Let's do this 6 millimeters or more. We'll have to see. So now that's way better. Okay. So now let's go ahead and save this guy. Let's go to General Assembly. Let's drop this in. Stop here in a few minutes. Stop sketch first. Now drop this in. Did I save it? Yes, I did. Okay, and then we're gonna go ahead and joint it. And again, we have 2 of these guys. This is rigid. Okay, I don't know why it does that. Okay, so once this guy then. There we go. Okay, good deal. Alright, so there it is. There's one. Oh, another thing. Excantry. Bodies. This one. Physical material. Metal. Aluminum 6061. Okay. Let's go ahead and drop this another one in. Okay, so now if I do this and I do this, oh man. Okay, well, not a problem to move it. There we go. Now we are looking good. So this is going to have 2 beams here, but what I'm seeing now is that this obviously is going to have to be more than 65 millimeters. So this is going to have to be 65. Oh, and then also it has to clear the thickness of this thing. Wherever it went, where'd it go? There it is. It has to clear the thickness of this. So it's like 0.4 plus this is 2.5 inches. So 2.5 inches is way under 90 from what I know. 2.5. Wait, that doesn't make any sense. .2 plus 0.4. Well, it has to be able to clear that. So basically it has to clear this thing. So let's just look at a 65mm clamp. I'm busy. Mount. Sorry about that. Somebody knocked on my door there. Can I get some good drawings of this thing or what? There we go. 56 to here, and then it's about a quarter. It's about quarter of an inch there. So 17 here plus 56. So 17mm plus 56 plus oops, 56mm plus 0.25 inches plus the height of the rails, so 60mm, because 2 rails, 30, so at least that, plus 2 inches on each side, because half-inch piece beam and another half-inch piece beam, so let's say 2 inches. Well, that's a big plate, man. So we're definitely gonna have to shorten the assembly here. Alright, there it is. So now we're gonna have box here, and then maybe have some sort of gusset something. Probably not, but should be okay. So we're gonna have 2 here to get it nice and stiff. These are gonna be wide, because these are basically going to be as wide as a spindle there. I have a big box, so we'll look into it. Because right now we're going to be up there on properties. 1137.931 divided by 16 equals. We're at 71 pounds, so I mean we could do another 30 pounds. Not a problem, and that's including the spindle, so we're doing pretty good so far. So I would like this guy to be at least 200 pounds of stiff material. So, and plate goes for $2.25 or something. So we look here, calc 2.25, I think it's like 2.5 per pound or something. So look at $500. And then about another $500 of other hardware, including this guy and electrical and stuff. So it's probably about $1,000 router, which sounds pretty good. Alright, so that's basically it for this video. Thank you guys for watching. If you like this video, please subscribe for more videos like it. This has been Steven from Legit Tech Tutorials and Green Engineers. I'll see you guys in my next video. Thanks for watching. Take it easy. Peace.